This is MA 108, section 6.2, and we're going to talk about the law of cosines. So the law of cosines says that when I have an angle alpha and a side A, so I have this angle alpha and the opposite side A, then there's this relationship of A squared, so A squared equals B squared plus C squared minus 2 times B times C times the cosine of A, or of alpha. So the relationship between alpha and A is what's important. I want to point out that you can use the law of cosines with right triangles or without right triangles, but if you used it with a right triangle and cosine was 90 degrees, then this would be 2 times b times c times 0, so this whole term would be 0, and then you just have a squared equals b squared plus c squared, which is the Pythagoras' theorem. So this would be the hypotenuse is equal to the square of the other two legs. So the square of the hypotenuse is equal to the square of the other two legs. So in this number 15 from our practice set, it's asking us to solve where we're given angle alpha, we're given side B and side C. So I converted angle alpha from 50 degrees 40 minutes to 50.67 degrees. And then we're trying to find side A. So we're given this, we're given this, we're given B and C. We're not given A, but we're given angle alpha. So I set up A squared equals, and then 7.03 squared plus 700 squared minus 2 times 7.03 times 7.00 times the cosine of 50.67, and then I just need to solve that for A. So this whole right hand side turns out to be 36.04, and so I take the square root of both sides and I get plus or minus the square root of 36.04, and since we're talking about a length of a side, I'm going to use the positive case, so A equals 6.003. So I found this one side. So now I just need to find the other two angles that I don't know. I know this side, and I know this side, and I know that angle. Those were all given to us. We just found this one, so we have to find these other two angles. So now that I have that, I'm just going to use the law of sine, which we learned last section, to find this other side. So the sine of alpha over A is equal to the sine of beta over B. So the sine of alpha over A is equal to the sine of beta, which we don't know, over B, which we do know. So I solve that for the sine of B. I simplify this, I multiplied by 7.03, and I get 0.9058. Then I take the arcsine of this number to get what is beta. So now I have beta, 64.93 degrees, and to find gamma, well, all I need to do is take 180, because that's how many angles are in the complete triangle, and I minus 50.67, which is what I found after I converted this from minutes and degrees, minus 64.93, which is what beta was, and I get 64.40, and so then that's my gamma. So I found A, I found beta, and I found gamma, using a combination of the law of cosines first, and I used that one time, and once I did that, I used the law of sine to find the other information.